At the end of this lesson, I expect you to be able to calculate the length of a side in a triangle in a situation where you are given two sides and the angle between those two sides. And I expect you to calculate the size of an angle in a triangle in which the three sides of the triangle are given. In the previous lesson, we looked at the sine rule and we used it to calculate sides and angles. But I should be quick to mention to you that it is not always that the sine rule can be used in any given triangle. Hence, the need for us to look at the cosine rule. Shortly, I'll be able to present to you a problem in which it will not be possible for us to use the sine rule to calculate a length in a triangle. But before we go into that, I want us to reflect on the questions that we had in the last lesson so that we check and see if you got the correct answers. I gave you two questions. The first one involved the triangle ABC, and you were required to find the length of the side AB using the sine rule. If you observed, in order for you to use the sine rule to find the side, you need to know the angle which is opposite the side that you have been asked to find. So in this case, we know to this side, the angle opposite is 38 degrees. Then you also need to have the length of a side. In this case, we have 15 centimeters. And to this 15 centimeters, we need to know the angle which is opposite. And in this case, the angle opposite to 15 centimeters has not been given. Meaning, the first thing we need to do is to find the size of this angle. Remember, in a triangle, the three angles must add up to 180 degrees. I hope you managed to find the size of this angle as 42 degrees. So that your calculation should have come out as follows. We are looking for the side AB, denoted by small letter c, divided by the sine of the angle capital letter C. This must be equal to, we have been given the length of the side small letter a as 15, divided by the sine of the angle A. At this point, we have to make the necessary substitutions. C is what we are looking for, so it remains the way it is, divided by the sine of the angle at C. The angle at C is 38 degrees, so we indicate sine 38 degrees. This is equal to, we are given the side A as 15 centimeters. This must be divided by the sine of the angle at A, which, as agreed, is 42 degrees. The next thing is to make C the subject of the formula. So we are going to multiply both sides of the equal sign by the sine of 38 degrees so that C stands out alone. So we have C over sine 38 degrees multiplied by sine 38 degrees. What we have done on the left hand side, we must do on the right hand side. 15 centimeters over the sine of 42 degrees must also be multiplied by the sine of 38 degrees. So that sine 38 and sine 38 there, we will divide, leaving us with C on the left hand side. On the right hand side, you were required to use the calculator and multiply 15 by the sine of 38 degrees, then divide by the sine of 42 degrees. After using the calculator nicely, you should have obtained 13.8014 centimeters, that is to 4 decimal places. As per standard, we must round off this answer to 3 significant figures and make conclusion that AB is actually equal to 13.8 centimeters to 3 significant figures. So for the first question, this is the answer that I expected you to get. Let's move on and look at the second question. In the second question, I gave you the triangle JKL with the angle at J as 25 degrees. The length of the side JK as 11 meters, and KL was given to you as 7 meters. You were required to find the size of the angle JKL using the sine rule. When we look at this one, we will see that the side opposite the angle that we need to find is not given, but we are given the side opposite to this angle which we have not been asked to find. But remember, in any triangle, the 3 angles must add up to 180 degrees. So if we can use the sine rule with this 25 degrees, the 7 meters, the 11 meters, and be able to find this angle, it will be possible for us to find the angle that we have been required to find by simply adding this to that and subtracting from 180. So we are going to start by finding the angle L. And this is what I expected you to come up with. The sine of the angle L over the side L should be equal to the sine of the angle at J divided by the side small letter j. Making the necessary substitutions will lead you into having the sine of L divided by the side opposite to the angle L is 11 meters. This is equal to the angle at J is 25. So we are going to have the sine of 25 degrees divided by the side opposite the angle 25, which is 7 meters. As usual, we have to make the sine of L stand out alone, so we need to multiply both sides of the equal sign by 11 meters. And what we will get is the following. The sine of L is equal to 11 meters multiplied by the sine of 25 degrees, everything divided by 7 meters. And at this point, you realize that meters and meters there will divide, leaving us with 11 multiplied by sine 25 divided by 7. At this point, I expected you to use your calculators to multiply 11 by sine 25 and divide by 7. If you did that nicely, you should have obtained sine L as being equal to 0.6641. After which, the angle L should have been found as the sine inverse of 0.6641. Using your calculators, the sine inverse of 0.6641 should have given you the angle L as 41.6 degrees. So, we have managed to find the angle at L as 41.6 degrees. But what we are required to find is the angle at K. As I said, these three angles must add up to 180. So the conclusion should have come out as follows. Therefore, the angle JKL is equal to 180 degrees minus the sum of 25 degrees and 41.6 degrees. And at the end of the day, I expected you to get 113.4 degrees as the size of the angle JKL. I hope you managed to get the solutions that we have obtained. And if you did, job well done, continue working hard. If you couldn't get these solutions, hard luck, and I expect you today to pay more attention so that you'll be able to get the questions that I'll give you at the end of this lesson correctly. Earlier on, I told you that the sine rule cannot be used in any given triangle. There are situations where the sine rule will fail to work. For instance, in this triangle ABC, in which AC is 8 centimeters, AB is 10 centimeters, and the angle at A is 60, and we are required to find the length of the side BC, it is not possible for us to use the sine rule. Let's just show it that it is impossible. If we are to state the sine rule, it is going to be A over the sine of the angle at A is equal to B over the sine of the angle at B, and this is equal to C over the sine of the angle at C. In order for this to work, out of the three ratios, we need to have one complete ratio and the one in which one is given and the other one is not given. So in this case, A is the side which we don't know, and in fact that is the one we have been asked to find. The angle at A is given as 60 degrees. So we have that one. So this ratio has to be used with another complete one if the sine rule is going to be useful in this situation. So let's check. The side B is given as 8 centimeters, but we don't have the angle at B. So it is not possible for us to use this and that in order to find this, because we have two quantities whose values we don't know. Let's check with the other one. The side C is given as 10 centimeters, but the angle at C is not given, meaning it will not be possible also for us to use this and that to find this, because this quantity and that quantity are not known. And if you have observed, we are only given one angle, meaning we don't have a way of finding any of these two, because that is only possible if two of the angles are given. Then we can use the angle sum of a triangle being equal to 180 degrees as a way of finding the third angle. Having justified that the sine rule cannot be used in this situation, we are going to use a general case of triangle ABC to derive the cosine rule, so that at the end we'll be able to use it and be able to solve this problem. So let's move on and derive the cosine rule. We have a general situation of triangle ABC, but the conditions are similar to the ones which obtained in the one which we failed to use the sine rule and have the solution found. The angle at A is given, the side C is given, the side B is also given. The task at hand is to find